The exact nature of light has puzzled man for centuries, even as early as the ancient Greeks, and the discrepancy of whether light is a wave or a particle still exists today. Light is most commonly perceived as a wave because of its wave-like properties seen in nature and along the electromagnetic spectrum. The energy produced traverses through space in a manner similar to ripples in a pond after a rock is thrown in. Dutchman Christian Huygens was one of the first to provide evidence for this theory in the mid-1600s, when he proved that light would diffract upon surfaces like a wave would. The more light was bent by an object, the slower it would move across it. Huygens' theory was opposed by Isaac Newton and his prism experiments in the late 1600s that proved light also had tendencies to behave like particles. This theory showed that light always travels in straight lines until disturbed in some manner, like by an edge or barrier. Newton's theory made sense until it was tested at a microscopic level in the double-slit experiment. Performed in 1801 by Thomas Young, he used a screen with a narrow slit, and when a light beam hit the slit, it spread out or diffracted into the wave-like properties until it hit another screen with two slits. Young observed the overlap of the light waves and concluded that light was a wave based off this constructive and deconstructive interference when the waves hit each other. This proved light was a wave because if light was a particle, then only the light going through the slits would show up on the other side. But if light's a wave, then the end result is very different. Only two beams go through the slits, but as soon as they do, they start to diffract, and that is exactly what Young's experiment concluded. About the same time, though, is when counter-evidence was given for light having more particle-like properties. Philip Leonard discovered that when light of specific frequencies is shined on a metal, it began to essentially kick off electrons. He called this the photoelectric effect, and discovered that different colors were responsible for this phenomenon. He determined that shorter wavelengths produce electrons with greater amounts of energy, which was completely contrary to the previous wave theories. Finally, in the early 1900s, Albert Einstein determined that light indeed had particle-like properties, despite the overwhelming amount of wave-like evidence. This led to his quantum theory that helped to develop the term photon, which in the end led to the formulation of quantum mechanics. Based off the work of Huygens, Newton, Young, Einstein, and so many others who attempted to explain how EM radiation can display duality, it's determined that light is both, because at times it behaves like a particle and at times it behaves as a wave.